Good afternoon, and thank you for joining us for today's webinar. My name is Sean Giordano, Vice President of Sales for Programmer's Paradise. In today's webinar, Mastering Data with CA Irwin Data Modeler, we will discuss the importance data quality plays within an organization and provide you with a view into establishing effective processes in order to help you achieve data quality. Before I turn the presentation over to Victor Rodriguez, Senior Software Engineer, I'd like to give you a brief overview of Programmer's Paradise. We've been in business helping customers for over 27 years, and we've enjoyed a strong 15-year-plus relationship with CA as an elite partner. Many of those years as a top reseller of the Irwin database modeling suite of tools. As an authorized vet education partner, our CA dedicated sales and engineering team provides database modeling and infrastructure design and training services which help our customers maximize their data modeling investments. We are a publicly traded company with strong financials. Our database worldview ecosystem helps our customers make an informed decision on what industry-leading trends and tools are available to you to help you within your own organizations. With that, I'll turn it over to Victor Rodriguez, Senior Database Engineer.
Thanks for attending, everybody. So as Sean mentioned, I'm the Senior Software Engineer here at Programmer's Paradise and specializing in data modeling primarily. And before that, I had 10 years of experience working with the CA Irwin modeling team. So if you are users of the CA products, you may very well have spoken to me sometime along the way. In this webinar, we're going to start discussing the topic of this current push for data quality. And in this first presentation, we're going to discuss the beginning to build this data quality process and how you can use the existing process you already have to build this process from the ground up. So let's look at the agenda for our topic today. First, we're going to discuss how we're going to start trusting our data, and then look at the obstacles and object lessons that may occur that prevent this process from occurring. Then we're going to discuss what essential pieces we need to this puzzle, and then how we can use our existing processes to tie in with those. And then last, we're going to look at the actual data quality steps themselves. So first, how do we trust our data or begin trusting our data? Data is a company's greatest asset in this day and age. And the question is, how do we begin to start using that information to make our process, or to build processes around that information to build our companies and best use our processes? Accenture recently had a survey that showed that 40% of CIOs still trust their gut over their BI. And the main reason for this is that they find, 61% of them find that it's hard to find good quality data, I should say. And it's hard to find that information to make their decisions. And the fundamental problem is that they don't trust their data. Data plus quality gives you information, and you cannot make educated decisions until you have solid information that we trust. When looking at possible obstacles in the same survey, there basically was, the question was, do you find people being the major obstacle? Do you find the process being the major obstacle? Or is it actually purchasing and acquiring software and educating your users in the use of that software? Basically, it broke down into three equal parts. So it's a combination of all three of these processes that are causing this prevention of data quality initiatives. So how do we use existing resources to start building this process without becoming too intrusive? Oftentimes, businesses will wait for some kind of silver bullet solution. You may ask, isn't the data warehouse, the ERP solution, supposed to be promised to do this, to kind of integrate our data? And the reality is that this is not always the case. The data within these silos of information are context specific, and until we actually create an overview of how this data communicates with itself and with other silos of data, we cannot own that data. And until we own that data, we cannot build quality processes around it. Remember the Nike the Nike i2 disaster from a few years ago, I should say, where Nike lost $100 million relying on the i2 to build a CMS system that would integrate with their ERP. The problem was that they assumed that the data would be able to be integrated easily, and it did not. So assuming that some silver bullet solution is going to come in, that a vendor is going to come in and sell you a solution, is not the case. This is not to say that you can't use an external vendor, but you want to own your data first. You want to know that you understand your data, you're the shepherd of that data, you understand it better than anybody else, and you want to get all that data corralled into some logical structure before you decide to implement some larger overview, larger process that you come in with to organize all of it. Regardless of what solution you decide for your data government process, there are essential components that exist to basically any concept of how we're going to organize this. One is defining metadata standards. The next is collaboration, or building a location where everybody can collaborate. Third is to build a structure that is a standardized structure across the enterprise so we understand how this is going to be implemented. Fourth is to define policies and standards across the entire enterprise. 5 is maybe the toughest step, which is to apply those cultural changes within the corporation. And last is to get from an as-is to a to-be environment. We know where we want to go. We know where we are now. How do we define a process from those 2 points? Data modeling and a shared repository for those data models will allow us to assist us in all of these 6 steps. If we use the data model repository as a hub for our entire process, we'll find that we can actually create a collaborative area where we can now report to our BI teams. We can integrate our data warehouse. We can implement a master data management solution. We can have our application developers speaking to the databases. They can model their designs and integrate them with the actual source data that they're going to be mapping to, and any kind of ERP solution as well. All of these can be integrated by using data modeling and a data model repository to define and standardize our metadata. Here we have a common representation of the master data management solution, and we'll see here, if you look towards the bottom, that the transformation of the data from its primary master location to its eventual data store and eventually to master data modeling would be the backbone of this entire process is a strong metadata management solution. So that strong metadata management allows us to now easily transform and map data from one master from one source to another, and we're going to discuss the steps to implement that. So why does metadata matter? We need to define our metadata. It's been throughout the ages arguments about what a definition even is. Some people feel that concepts are so ever-changing that they need to that they cannot truly be defined. So every application, every single silo of data is going to have a different standard of definitions. On the other hand, you have this belief that definitions are extremely specific, they're extremely strict, and they're always and never changing, always the same thing. The reality is that definitions are somewhere in between, but we still need to define everything. For example, if I say a desktop, you may think of an actual physical desktop, or you may think of your computer desktop. But if I say to you, put the pen on the desktop, I cannot define that process until I actually have a definition to rely on for, that we have a shared definition to work with. An example of data being too strict is with phone numbers, for example. So let's say that your phone number in your data table is a single entry. As time goes by, you may have added a new area code as your application developed, and we need to add that to a valid value list. Alternately, maybe now people have cell phones, people have home numbers, people have Skype phone numbers or Google Voice, and now they want to collect this data somehow. If you are strictly enforcing just the one concept of phone number, obviously we cannot capture that data. On the other hand, we can't be too flexible with our definitions either. If we define a phone number as an XML tag and we allow the user to enter the data, put in their tags to identify each one of those numbers, who's going to define those standards? Is everybody going to use a different standard? It's going to be very hard to integrate that data somewhere down the line, and you're just passing the buck and causing an application, or assuming an application developer will come along and resolve the issue for you. So what we need to do is we need to know exactly what we're talking about with each level of the data, and then we need to create relationships between that data. And the best way to do that is to build models around everything. So in this first example I have here, We actually have two source models. One is the Oracle source model, which is in the left upper area of the pane, while we have a SQL Server source model, which is in the lower left. And you'll notice that we're using different naming standards and different data types on those databases. We have a Teradata data warehouse model to the right. And the goal here is to create a relationship between these objects. And how do we keep and enforce that relationship so it's easy to manage in the future? By using the Irwin data modeling design layer architecture, we actually can go and create relationships between these models and between the objects within them. We'll see here when we're trying to synchronize the data warehouse model to our Oracle model that because we've created this linkage, we now have the tool itself managing the relationship between these objects. We now can just in one step say make a change to our source model, and now we know that change needs to be rolled out to the data warehouse, or that maybe the data needs to be transformed. By defining strictly the structure of the data and then mapping that relationship between one model and another, we now can have the tool itself manage that relationship between those models, which of course takes that burden off of your team. Here's another example where we have a translation between two models in two different languages. In the upper left, we have an English model. In the lower left, we have a Spanish language model. But we have a physical model, a physical database that we need to correlate those logical designs to. Once again, by creating design layers, by linking the models to each other, creating that relationship between the models, the Irwin software allows us to go and define a glossary of terms, so we see how the English names above are mapping to those physical abbreviations, and we see how the Spanish names below are mapping to those same abbreviations, and we can define new ones here as well. Thanks to the fact that we've now defined those glossary of terms, we can now go and synchronize our physical design with our logical design, and not only have we allow us to do this synchronization. But now when we export a change, for example, in the example to the upper left, we're looking at exporting the employee ID physical column into our Spanish language model. And we'll see the resulting to the right, to the lower right, we see the resulting attribute being added to the design. And we see the translation has occurred. So now this saves us time. We've integrated our models. We do not need to lead somebody to have a translator to do this translation for us or to verify our design. We can actually have the software itself handling this level of design. And this is all permissible because we've defined our metadata, we've stored it centrally, and we're allowing to create relationships between those stored models. The next step of our process is to create a collaborative area where we can all share this design, our best practices, and to start building these glossaries and start building a process for our data quality initiatives. Irwin allows us to store our models within the Model Manager repository, and by sharing our designs within that repository, we can actually share these templates with our users. We can define that model lineage and see the version and history of each one of those models. We can see who's doing using what models and what changes occurred at one time in history. And we also can run centralized reports against all that metadata. That's another very key point, that if you need to share that data with your rest of your team, now you have a collaborative location where you've actually stored all of your best practices, all of your models, all of your design specifications, and you can share that with the rest of your team. You can update your application data to your database design or vice versa. You can define a glossary of terms like we mentioned in the translation example, and create standard abbreviations, enforce those, push them out as best practices, and eventually make them required for any design, any future design. And once we've created these templates, whether they're whether they're referential integrity specifications, whether they're shared domain objects, even shared tables that all applications for a certain team will need to share that will be reusable, that in doing so, you can actually share them in this collaborative repository. An example of where collaboration or creating a collaborative space is very important is when we look at the recently in the news where they were looking for a new director of national intelligence. This department was created after September 11th to oversee the 16 silos of data within these, the United States national security, and there was a lot of cultural resistance to this new leadership position. So the question was, how do we start to build that collaborative space? What they actually did was they built a space, which is actually a forum, which allowed their users to go and share their resulting, their current analysis, any kind of information, data that they wanted to share with each other. And then this collaborative space, other analysts were able to go across departmental silos and look at that data, give them information, related data perhaps that they had also seen that might be important to any kind of analysis. And by creating this collaborative space, you immediately begin to encourage a collaborative culture within internal society. And we're seeing that at every level, even in something as ingrained as these cultures that we've seen before. So how do we formalize this organization? How do we begin to build this structure around our existing processes? First of all, we need to identify what those processes are. We are already governing our data informally. Sometimes users may simply have spreadsheets that they're storing their data in, and they're pushing those along from one member of the team to another. But without sharing that information, obviously, we're creating these silos of separation between our data. But we need to locate those assets. We need to identify who is taking leadership positions in those groups. There are probably already standard models that have been defined that users are currently using. There are glossaries that have been defined for each one of those processes. There are reusable application functions that have been created, etc. And we need to find a place where we can identify who's doing what, see which processes are helping, which processes are hurting, and then start to integrate that into one standard process across the corporation. If we can identify the processes that are already in place, we can implement new processes that aren't too intrusive. The key here also during this assessment phase is to look at your current resources, your actual employees, and see who is a good candidate. Eventually, somebody's going to have an enterprise view of your process. It's going to have to be your information officer, for example, if you want to have a labeled leadership role. And that person is probably already available. You probably have good candidates, and we need to identify them as part of this process, this assessment. So we need structure. The model manager is actually going to allow us to formalize our structure across our existing process. We're going to be able to link our models, like we mentioned before, start building a relationship between those models internally. Are we going to see applications? We see databases. We see a data warehouse, perhaps, a master data management initiative. And how do those different processes all relate to each other? We can build those processes internally. We can store them in the model manager, and we can use that to enforce it across the company. And we need to start to formalize that structure within the model manager itself. We can create libraries within the model manager, and those libraries can be fractured or fragmented across depending on what our requirements are for our process. And we're also going to use security roles to formalize what we did before when we were doing our assessment, and we're trying to collect those people who are doing these roles currently. How do we formalize their roles and their requirements within the security structure itself? Here we have a suggestion for the model manager, a typical suggestion for creating your model manager repository. And in the typical definition, what we're doing is we're actually going to grant the modeling team full access to the development and test libraries, but read-only access to the production libraries, while testers are granted read-only access to the test and production libraries. This is a pretty straightforward method of creating breaking down your projects. There's also an enterprise design which is suggested, and this could maybe fit your needs better. And in an enterprise design, you're creating a application-specific library, and then you're merging those enterprise models into the libraries based on the relationships between your source models and your application-specific models. One person in the group would be responsible for integrating all the models in that enterprise model, but it would not be required of all the other modelers in the team. There are other suggested possible structures. One would be that it would be model specific, in which, or modeler specific, I should say, in which you are defining libraries around each modeler's actual models. It could be DBMS specific. If you have Oracle models or many Oracle source models, you can put them all in one place. If you have a data warehouse in a specific design, that data warehouse specific design could include having a data warehouse model, and then having all your source models that relate to that data warehouse model in one library, and you could break it down in those. Enterprises normally find that what you actually need is some combination of all of these different processes. You may need a typical implementation for your test environment, but you may need enterprise level for your application designers. And so you can mix and match, but the goal is that eventually, once you've defined the structure, you want to be able to stick with it. You want to be able to make sure that everybody knows who their roles are and how they fit into the entire overall design. And we do that by defining officially using the security within the model manager software itself to define these different roles. Those can go anywhere from administrator down to viewer, and you can actually, there's a lot of granularity in the way you define these users. They can be, the administrator has overall security privileges, as well as the ability to have all the permissions of all the other roles, but they're the only ones that can actually go and create new libraries, and I should say create changes to the security within the model manager itself. The architect would be able to create libraries, but would not be able to change security privileges, while a modeler would just be able to model, and viewers, of course, would have view-only permissions. But the key in structuring this is that you can actually mix and match. So you may want to make somebody an architect for one library, a modeler in another, or just a viewer in another, and you have that flexibility in using the canned security profile, the canned security profiles, I should say, or in creating your own customized profiles, would have granularity all the way from the model manager level all the way down to even just the subject areas within particular diagrams. So another key point that we mentioned initially is establishing standards. These standards need to be enforced across the entire enterprise, and they may be coming externally as well. For example, there may be government regulations that change, and they periodically do change, actually. So the goal is, how do we roll out these changes to our team internally and externally, and how do we synchronize these changes? By using the model manager software, we can actually create a repository. We can create a repository where we're generating our reports centrally, to share that with our business analysis team. And we can create a bidirectional hub in which those standards are being exported to the rest of the team, to the rest of the enterprise, I should say. And you can also update those policies if, for example, your enterprise level standards have changed, or if your standards are changing due to government regulation changes. And now we have one central location where we make the update in one place, and we have now made it available to the entire design team. The next step is the hardest part, and that's cultural change. Data quality requires a change in culture, and it's a process. There's no easy solutions for it. Like any habit, it gets easier with time. So the longer, the more often you do something, this is an iterative process, and every time that we iterate through the process, the data becomes cleaner, the process becomes simpler, the habits become more ingrained, and there's less and less bad data to work with. So this is a slow process of slowly integrating our data, creating these relationships, transforming the data that we need to transform, and as we're actually building this process, we see that it becomes easier with time. We have to replace those bad habits with good ones. The process needs to be bottom-up, but also top-down. A bottom-up solution, obviously, many hands make light work, and if we all chip in and everybody pays attention to what they're doing and make sure that they raise their hand when they see bad data or bad process, that we can start to pick up those problems before they become systemic. But this also needs to be encouraged from a top-down point of view. We need management to encourage these processes, and we need to support them, and also they need to reward those users who take initiative to actually begin this process. So it has to become part of the standardized process of grading our data as well, and our performance, I should say, as well. So what are some good habits? First of all, we should model everything. You can model applications. You may have UML models that you're defining your applications in. Any DBMS you have laying around, your data warehouses, your ERP systems, and even non-standard NoSQL databases or UML models, etc., can be synchronized using the Irwin software. Irwin has a meta integration modeling bridge built into it. This actually allows you to take in many different kinds of, basically any kind of XML standardized design into and build a model around it. It also, you can, for example, reverse engineer an Netezza database using an ODBC link. So once again, whether you can define an ODBC link or whether it's something that can be standardized into some kind of XML format, the key is that you can probably model it in an Irwin diagram, and you should. We should model everything, even if it's just data that's in a spreadsheet. It should be modeled. Another key point is to remember to model your data entry. Very often we forget to think about the data itself that's coming in, and we're modeling around a process, and we're not thinking about the actual data. So we think, or we should consider, I should say, when we're designing our models, what valid values are supported here? Do we have a list of discrete values? Is there only 4 zip codes that we need to look at? Is there only 50 states that we need to be looking at, etc.? So if we have those discrete values, if we know what they are, model your valid values. Is this value nullable or not? If I'm developing an application, I need to know whether I'm going to encounter null values or not within my data fields. If I know that as part of my design, I prevent bad data from entering. No new bad data in means no garbage out. Next, we want to make sure, as part of our modeling our data entry, we want to make sure that we're also looking at the proper data type and domain linkage. Once I know what that is, if I have a certain domain that's being used, it's a centrally defined domain, and our data type's all in sync, once again, we know what kind of data we're expecting to see coming in. My application developer knows what to expect, and we can also identify bad data right away. Once again, we want to keep less garbage from coming in as we're cleaning the data that we already have in our systems. Lastly, we want to make sure that we own our data. We want to be a good shepherd. Don't pass along bad data. If you see there's a problem in your process, then make sure you raise your hand and be vigilant. Make sure that nobody can see the entire enterprise. You can't rely on somebody else to tell you that this is the proper or improper method of doing your design. If you see that something we've overlooked, maybe your application does not make sense in terms of your database, maybe the definition is too vague, maybe there's an important concept that has not been modeled. If you are more intimate with your application, more intimate with your data than anybody else, make sure that you raise your hand and say something, because that is just going to become a systemic problem down the line. If we can encourage that early on, we can start to build good data standards for the future. The sixth step is to model our 2B model, or to define our 2B model. So we know where we are now. We've modeled it. We've reverse engineered it. For example, maybe we have a certain set of databases that we're reverse engineering against, and we know what our 2B model is. Maybe it's a data warehouse that we need to integrate these sources into. By using our data models and using the model manager to store them and to create these relationships, we can start to see what is the ideal 2B environment. Compare the as-is environment to that 2B environment and start building a process there. Are there tables I need to be building? Are there missing, do I already have some of the data I'm looking for? Are there tables that have overlapping data that I need to start integrating? These are all things that we could start seeing, and we can start building a process around it. We can have a history, a lineage to that process, and we could step back if we need to, or step forward as we go along. So just to recap what we discussed. Make sure to treat your data like the asset that it is. Data quality is what creates information. We cannot make informed decisions until we trust our data, and we want to make sure we have data quality. Strong metadata definitions plus good habits give us good data quality. Data modeling allows us to structure our metadata, and the model manager allows us to store that data, metadata, within a central repository. Data quality is a process that requires cultural change, and we need to make sure that we encourage and enforce those standards across the entire culture. So the key point, takeaway points from all of this is to remember that you may already internally have assets that you are overlooking, that there's already a process, business process informally occurring internally, that your users are already starting to attempt to design structures to their processes, and to if we give them a collaborative location where they can start to build a culture of sharing and standardization, that we can now help push that out across the entire enterprise and to share those standards with other team members outside of your data initiatives. Whether that's your business analyst team or a BI reports you need to report. So this is what the kind of strengths of building this kind of metadata structure, this central metadata repository. And I just wanted to quickly, I have a blog that I've recently put up, and I wanted to kind of promote it here and mention to everybody that if you'd like to visit my blog page, that's the link there, the top link there. Also, you can follow me on Twitter at Max Data Modeling, and there's also a Maximum Data Modeling group on LinkedIn. If you if you happen to be there and you want to look for it, you'll find me and a bunch of other members there as well. And I'd like to open it up to any questions anybody might have at this point.
All right, thank you, Victor. It looks like we don't have any questions here. So real quickly before I send everybody on their way, I hope you found this presentation useful today. This presentation will be posted up on the website, www.programmers.com. So please visit that link for not only this presentation, past presentations, but also an agenda of the upcoming presentations that we'll have around data modeling. You know, again, as I said earlier, we've been in the business of selling software and IT services to our customers for over 27 years. And one of the things that I mentioned at the very end of the intro was, you know, our publicly traded status and our strong financial position. And the reason why I think that's important to you is that we've been around, we're an established company, and we intend to be around for many years to come, providing value to our customers. One key area there is allowing our customers the option to pay over time. We call it our FPO program. So if you don't have budget today for your data modeling projects or any software or IT-related projects that you guys might have, we have the opportunity to work with you and build a flexible payment plan around you know, your company's budget situation. So with that, again, thank you very much for attending today's session, and we hope to see you on future sessions.